Hello. In this class, today we are going to discuss about one of the important topic for 8th class students, that is polygons. Polygons is one of the interesting and very important topic. So today we are going to discuss about polygons. What is the interior angles of a polygons and what are the exterior angles of a polygons and number of diagonals of a polygon. So these three topics are very interesting and very important for 8th class students. So first we need to discuss about what is polygon. Polygon is nothing but it is a closed figure with some number of sides. For example, polygon begins with a triangle. I mean, the least polygon is a three-sided figure that is called as a triangle. With two sides, you cannot make a polygon. So the polygons begins with triangles. So the least polygon is a triangle. And a triangle means you know that it is having three sides. If you go for the four-sided figure, we can call it as quadrilateral. And if you go with a five-sided figure, this will be pentagon. So like that, there are different types of polygons, and polygons are given names according to their number of sides. For example, three-sided figure, it is called as a triangle. This four-sided figure, it is called as a quadrilateral. And if it is having five-sided, it is a pentagon. So like that, hexagon, nonagon, decagon. Decagon means having 10 sides. Nonagon means it is having 9 sides. So there are different types of polygons are there, but the least polygon and least sided polygon is called as a triangle. So because we cannot make a polygon with two sides, so triangle, quadrilateral, pentagon, hexagon, like that some different types of names are there according to number of sides. But here one interesting topic is there, that is what are the exterior angles of a polygons and what is interior angles of polygons and how many diagonals a polygon is having. So you know the meaning of diagonal. Diagonal is nothing but joining of their opposite sides. For example, if I join these two sides, it is called as the diagonal of this quadrilateral. But if you think about a triangle, you cannot make a diagonal in this triangle because how can we make, this is a vertices and you cannot join. Again, if you join these two, again it will become a side. So in triangles, there are no diagonals. So how many diagonals a polygon is having, that is today's topic. And what are the interior angles of a polygon and what are the exterior angles of a polygon. So these are one of the interesting concepts for polygon, and today we are going to solve some different problems according to these topics. So for example, if you take any polygon, for example, I am drawing here one polygon. So this is a polygon. So 1, 2, 3, 4, 5, 6, six-sided polygon. So now I want to know what is the sum of its interior angles. I mean all angles. If I add all angles of this polygon, what is its sum? That we require to know. So the sum of interior angles or exterior angle of a polygon or number of diagonals. These three topics depends purely on its number of sides. So polygons, sum of interior angles and its exterior angle and number of diagonals completely depends on its number of sides. For example, here 1, 2, 3, 4, 5, 6 sides are there. So what are the sum of its interior angles if you want to know? So this we can say that if you join these two and these two and these two, it become divided into 4 triangles. It is become divided into 4 triangles. You know that the sum of angles in a triangle is 180 degrees. That is the basic thing we require to know. The sum of 3 interior angles. The sum of 3 interior angles of a triangle is 180 degrees. So by this, the angle sum property of triangle, we can find the sum of angles in a this polygon. So this is 180 and this is also 180 and this is also 180 and this is also 180. So the sum of these 3 angles is 180, the sum of these 3 angles is 180 and the sum of these 3 angles is 180 and the sum of these 3 angles is 180. So the sum of the total angles in this polygon is 4 into 180, like that we can find. but that is not a proper thing to find the sum of interior angles of a polygon. So for this purpose, today we require to learn how to find the sum of interior angles of a polygon. So sum of interior angles of a polygon, there is a direct formula, that is n minus 2 into 180 degrees. This is the sum of interior angles of a polygon. This is the formula to find the sum of interior angles of a polygon. For example, here n indicates the number of sides of that particular polygon. For example, if you take the triangle, there are 3 sides. For triangle, there are 3 sides. If you substitute 3 in place of n, 3 minus 2 into 180, that becomes 1 into 180. So the sum of interior angles of a triangle is 180 degrees. For example, if you go for the quadrilateral, you substitute in place of n as 4, then it becomes 4 minus 2 into 180. So that is equal to 2 into 180, that is equal to 360 degrees. So the sum of interior angles of a quadrilateral, I mean 4-sided polygon, is equal to 360 degrees. For example, if you want to go for the pentagon, I mean the polygon which is having 5 sides, you substitute 5 in the place of n. So 5 minus 2 into 180 degrees, that is 3 into 180 degrees. Like that, we can find the sum of interior angles of a polygon by using this formula, that is n minus 2 into 180 degrees. So this is the basic thing. While we require to solve some different types of questions, the interior angles of a polygon is n minus 2 into 180 degrees. So now one interesting thing, we require to know that there are 2 types of polygons, that is regular polygons and irregular polygons. So what are regular polygons and what is irregular polygon? For example, if I draw a pentagon is here like this. So pentagon also we can draw like this also. So this is also a pentagon and this is also a pentagon. But pentagon means, I mean, it is having 5 sides. In this figure also it is having 5 sides. These 2 are pentagons, but this we can call it as a regular pentagon. So this is irregular pentagon because when all sides are equal in a polygon, if all sides are equal in a polygon and it becomes all interior angles, each interior angle also equal. But in this pentagon, all sides are not equal. There are different sides. It is having different measurements and therefore it is not a regular polygon. Regular polygon means all sides are equal and each interior angle also equal. So such a type of polygons are called as regular polygons. So regular polygons means regular triangle, regular quadrilateral, regular pentagon. So regular means you need to understood, that is each side is equal and each interior angle also equal. For example, here one interesting concept is there, that is how to find each angle in a regular polygon. How to find each angle in a regular polygon. If it is a polygon is a regular, how to find each angle in a regular polygon. So that is, you know that the sum of angles, I mean sum of interior angles of a polygon is n minus 2 into 180 degrees. Now we require to write the formula to find each angle in regular, I mean in regular polygon. So if you want to write each angle in a regular polygon, the formula is the simple formula n minus 2 into 180 by n. So this is the formula to find each angle, each interior angle. I'm sorry, this is each interior angle. This is interior angle of a regular polygon. If you want to find each interior angle of a regular polygon is n minus 2 into 180 by n. So this is the sum of all interior angles of a regular polygon, and this formula indicates us each interior angle of a regular polygon, that is n minus 2 into 180 by n. So here another one topic is there, that is exterior angle. This is very interesting. You take any polygon. For example, if you take triangle or a quadrilateral, whatever it may be, if you extend all these sides in clockwise or anti-clockwise like this, if I extended this one like this and extended this one like this and extended this one like this and extended this one like this. So Here you can find some exterior angles. This is one exterior angle and this is one exterior angle and this is one exterior angle in a triangle. And if you go for the quadrilateral, this is the given quadrilateral. I extended all these sides and here I got 4 exterior angles in this quadrilateral. If you go for the pentagon, you will get the 5 exterior angles. If you go for the decagon, you will get the 10 exterior angles. So like that, here one interesting concept is the sum of exterior angles in any polygon. If you say this is angle 1, this is 2, this is 3, the sum of exterior angle in a triangle is angle 1 plus angle 2 plus angle 3 is equal to 360 degrees. The sum of its exterior angles is equal to 360 degrees. But if you go for the quadrilateral, this is angle 1, this is angle 2, this is angle 3 and this is angle 4. Here also angle 1 plus angle 2 plus angle 3 plus angle 4, again it is equals to 360 degrees. So my concept is the sum of exterior angles in any polygon, the sum of exterior angles in any polygon, it will be equals to 360 degrees. So how to prove the sum of exterior angles is equal to 360 degrees and how to prove the sum of interior angles of a triangle is 180 degrees, this I will explain you in the next class. The proofs about sum of interior angles of a triangle and exterior angle of a polygon is 360. That will be explained in the next class. But here every student should know that the sum of exterior angle of any polygon is equals to 360 degrees. So exterior angle concept is very, very interesting. Now I am writing here one concept, that is exterior angle of a polygon is equal to 360 degrees. Now I want to tell you what is each exterior angle of a regular polygon. What is each exterior angle of a regular polygon? This is each interior angle of a regular polygon. But here I want to tell you what is each exterior angle of a regular polygon. I mean regular polygon. This is the interior angle. Here I am going to tell you what is the each exterior angle means. This is very simple, 360 by 10. So this is the each exterior angle of a regular polygon. Here every student should be know this word, that is regular. It is these two formulas are applicable for regular polygons only. So already I told you what is regular polygon. So this polygon, the sum of all exterior angles is 360. It will be applicable for all regular or irregular. And the sum of interior angles of a polygon n minus 2 into 180, it will be applicable for regular or irregular. But these two formulas will be applicable for only regular polygons. This is the formula to find the regular polygon interior angle, and this is the formula to find each exterior angle of a regular polygon. So these two formulas are very, very important to solve some different types of questions. Now I am going to tell you one important concept. For example, this is a pentagon. So how many diagonals we can draw? Diagonal means I told you to chain the opposite vertices. So if I join like this, like this, we can write some different types of diagonals for a pentagon. So by drawing like this, we cannot find easily number of diagonals in a polygon. So here, how to find the number of diagonals without drawing by seeing its number of sides. So the formula to find the number of diagonals of a polygon, this is also very interesting concept, that is n into n minus 3 by 2. This is number of diagonals of a polygon. N into n minus 3 by 2 to find a number of diagonals in a polygon. Here n indicates the number of sides for a polygon. Here, for example, you know that there is no diagonals for triangle, because if you substitute n is equal to 3, what happened? You see, this is 3 into 3 minus 3 by 2. This becomes 3 into 0 by 2. This is 0 by 2, that is equal to 0. So there is no diagonals in triangle. So already I told you the diagonals for triangle is 0. We cannot draw diagonals for the triangle. So this is the formula to find number of diagonals in any polygon if n indicates the number of sides. Pentagon means you want to substitute n is equal to 5. Decagon means you want to substitute n is equal to 10. Quadrilateral means you want to substitute here 4. So like that we can find the number of diagonals for a number of diagonals in a polygon. So by using these 3 or 4 formulas, we need to solve some different questions in 8th standard. There are some interesting questions are there. Today I am going to explain those interesting questions in this class. The first question here, it is given that the first question is, how many sides? How many sides has a regular, this is very important word, regular poly means polygon, each angle measures 108 degrees. Here each interior angle, each interior angle is given as 108 degrees. This is very interesting. How many sides has a regular polygon? Each interior angle measures 108 degrees. So one polygon is there, that is regular polygon, and each interior angle is 108 degrees. He is asking how many sides. So what type of polygon it is asking. So I already told you each interior angle of a regular polygon is the formula, that is n minus 2 into 180 by 2. So here according to the given question, each interior angle means n minus 2 into 180 by n, that angle is given as 108 degrees. So by using this formula, it is easy to find number of sides. Now n minus 2 into 180 is equal to, if you go for the cross multiplication, 108n. So now n into 180, this is 180n minus 2 into this one is 360 is equal to 108n. Now if you bring this one, 180n minus 108n is equal to 360. Here you require some algebraic concepts. So now 180 minus 108, you know that 72n. This is 72n. Now this is equal to 360. Now n is equal to 360 by 72. 36 ones are 0, 36 twos are. Next 2 ones are 2 fives are. Therefore n is equal to 5. So you know that n is equal to 5 means it is a 5-sided polygon. So it is a pentagon. So in this question is given that each interior angle measurement, and it is also a regular polygon. So by using this 108, you know the formula, that is to find the interior angle of a regular polygon, that is n minus 2 into 180 by n. So n minus 2 into 180 by n is equal to 108 degrees. If you solve this, you will get n is equal to 5. So by seeing this, we can say that it is a pentagon. So because n is equal to 5, we got. So this is also one of the interesting question. It is belongs to for 8th class standards students. So I am going to another one interesting question that on the basis of this interior and exterior angles, and some questions we need to solve on the basis of diagonals also. Here my second question is, prove that the interior angle of a regular pentagon. So I am not going to write the entire question. Prove that the interior angle of regular pentagon. Prove that the interior angle of a regular pentagon is 3 times the exterior angle of regular decagon. So this is very interesting. Here the question is, interior angle of a regular pentagon should be equals to the interior angle of a regular pentagon is equals to the 3 times of exterior angle of a decagon. So this is the relation between the pentagon and decagon, and one is interior angle and another is the exterior angle. To prove this one, first you find the interior angle of a regular pentagon. So how to find the interior angle of a regular pentagon? By using this one. So interior angle of regular pentagon is equal to, we know that n into n minus 2 by n. So pentagon means, you know that 5 sides, it is 5 into 5 minus 2 by 5. So here, sorry, I'm sorry. So interior angle of a polygon is n minus 2 into 180 by n. This is the formula to find the interior angle of a polygon. So here pentagon is the given. So you write n is equal to 5. That is 5 minus 2 into 180 by n is equal to 5. This will become 3 into 180 by 5. If I divide this, 3s are and 6 are. So this is 3 into 36, 8 and 108 degrees. This is the interior angle of a regular polygon. So here the question is, prove that the interior angle of a regular pentagon is 3 times the exterior angle of a regular decagon. So this is my interior angle of a regular pentagon. So how much I got means 108 degrees. Now you go for the exterior angle of a decagon. Exterior angle, each exterior angle you know that 360 by n. So exterior angle of decagon is equal to 360 by n is our formula. Here you can write 360 by 10, that is equal to 36 degrees. That is equal to 36 degrees. So here n is equal to 10 I take because it is a decagon. Therefore the each exterior angle of a decagon I got as a 36 degrees. By see these two values, you can say 108 I can write as 36 into 3. So that is equal to 108. So this is 3 times of 36. This is 3 times of 36. I mean interior angle of a pentagon is 3 times of exterior of angle of a decagon. So like this we can prove that by given question, first you find the interior angle of a pentagon and afterwards you find the exterior angle of a decagon and you form a relation between these two. This is 36 degrees, this is 108 degrees. 108 degrees I can write 36 into 3. Therefore, it is 3 times of the exterior angle of a decagon. So this is also one of the interesting question to prove. And I am going to another interesting question. This is also very interesting. So these are the very interesting and important questions for all 8th class students who are facing their annual examinations in CBSE, by the by state also. My third question is, the exterior angle of a regular polygon is 1/3 of its interior angle. The exterior, third question, exterior angle of regular polygon is equal to, regular polygon is equals to 1/3 of its interior angle. 1/3 of its interior angle. How many sides does the polygon is having? Here number of sides are not given. So here one information is given, that is exterior angle of a regular polygon is equals to 1/3 of its interior angle. So you know that what is the exterior angle's formula? Exterior angle of any polygon is equal to 360 by n. 360 by n. So exterior angle of a regular polygon is 360 by n is equal to 1/3 of interior angle. Each interior angle of a regular polygon, you know that is n minus 2 into 180 by n. So this is the given information. Now you require to solve this question by using your algebraic knowledge. So this I can write as 360 by n is equal to 1 into this one is n minus 2 into 180 by 3 into n is 3n. 3 into n is 3n. Here 180 ones are, 180 twos are. Here n cancel. Now I got 2 is equal to n minus 2 into 1. I mean 2 is equal to, this is 2 and here it is n minus 2 by, what is I got? 3. So this is the simplification And if you go for the somewhat lengthy means, if you want to write some steps means by going for the cross multiplication, you will get this statement. Again, if I go for the cross multiplication, so n minus 2 is equal to 6. So n is equal to 6 plus 2. So n is equal to 8. So this is n is equal to 8 is my answer. I mean that polygon is having 8 sides. That polygon is having 8 sides. So here the given information is exterior angle of a polygon. So that is 360 by n is 1/3 of its interior angle. 1/3 of, I wrote the interior angle formula. So I just simplified, then you will get the value of n. So this polygon is having 8-sided polygon. So we are going to another interesting topic, interesting question, that is on the basis of diagonals. On the basis of diagonals. So that is my fourth question. If you observe this question, you solve some questions depends on number of diagonals of a polygon. So what is my fourth question means? If a regular polygon has 27 diagonals. It is having 27 diagonals. Find its each interior angle. So this is very interesting. So here diagonals are given, number of diagonals are given, and he is asking what is its interior angle. First you require to know what type of polygon it is. I mean, if you want to find the number of, each interior angle, first you require how many sides that polygon is having. So for that purpose, I am using this information, that is given the 27 diagonal polygon. It is a 27 diagonals polygon. By using this information, first I will find what type of polygon it is. I mean, how many sides that polygon is having. Afterwards, I am going to solve what is its each interior angle. So here given information is that regular polygon is having 27 diagonals. I already told you to the formula to find the number of diagonals in a regular, polygon, that is n into n minus 3 by 2. So here, according to the information, number of diagonals means n into n minus 3 by 2 is equal to 27 is given. So here n into n minus 3 is equal to 27 into 2. So n into n minus 3 is equal to 54. So this is how to solve this question means you can solve this question by factorization also, but factorization is somewhat different. So here what I am doing here, n into n minus 3 is equal to, I can write 9 into 9 minus 3. This 54 I can write 9 into 9 minus 3 means 9 6 are 54. So I wrote here to compare the values, n into n minus 3 is equal to 9 into 9 minus 3. So now n is equal to 9. If you compare the values, n is equal to 9. So by this we can find the number of sides of the polygon. So it is a nonagon. So therefore it is n value I got. By this information you can find the each interior angle, that is n is equal to 9. Now each interior angle is equal, the formula is n minus 2 into 180 by n. So n is equal to, I got 9. This is 9 minus 2 into 180 by 9. So now 9 ones are 9 20s are. 9 minus 2 is 7. 7 into 20, that is equal to 140 degrees. So like this we can find the each interior angle of this polygon. So in this class we learn what is polygon and what is regular polygon and what is irregular polygon and what is the sum of its interior angles and what is the sum of its interior angles and how to find the each interior angle and how to find the each exterior angle. By the way, the relation between number of sides and the diagonals and how to find the number of diagonals of a polygon, and I solved some different types of question on the basis of these three concepts: exterior, interior and number of diagonals. So if you practice these type of questions for your annual preparation, it is very easy and it is very interesting. Thank you.